Good afternoon. Thank you for attending our Filtration and IAQ webinar. I'm Buck Nye, president of HC&I Company. Today's webinar is going to be presented by Jim O'Donnell. A couple of housekeeping items. There's a Q&A box should be at the bottom of your screen. We ask that you ask questions there, and we will go through at the end of the presentation and answer them. There will also be a short survey after the webinar. If you wouldn't mind, please taking a few moments and fill that out. We would appreciate it. We have 2 more upcoming webinars. Kitchen Ventilation Part 2, which will be in April, and in May we'll be doing DOAS Psychrometrics. See, we have a question already here. Doug Barnhart, I'm going to allow you to talk. Doug, you have a question? Okay, guess maybe he does not. All right, well, Jim, you want to get started?
Yes, sure. Thank you, Buck. Yep, let's get started. My name is Jim O'Donnell. There's my contact information down in the lower left-hand corner. Just a reminder, we can provide a PDH credit for this. And then afterwards, we'll have a summary of the questions and answers. We'll have a link to this recording. And then also to, like Buck said, there is a short survey. We appreciate if you answer that. So we're going to talk about filtration and indoor air quality today. 3 broad topics. 101, basic information. I'll try to go through that fast. We'll review the changes to the recent Ashrae standard or recommendation for the building readiness guide. And then lastly, we'll talk about, give you just a quick overview of 3 different products that HC&I represents that we feel could help you in your indoor air quality and filtration endeavors. All right, so today's focus from the Ashrae Task Force, this is the filtration and disinfection. Under disinfection, I'm going to focus on or just touch on ultraviolet UVC. Everybody's familiar with that. And then the other one that's a hot topic is bipolar ionization. And then lastly, we'll talk a little bit about in-room or portable air cleaners. Just basics. So you have your indoor air quality triangle made up of filtration, pollution, as well as source control. Just what is in air? So 1% or less than 1% is aerosols, and then the other 99+% is gases made up primarily of nitrogen and oxygen. Next, for aerosols, we have aerosol is a fine particle that's suspended in air. There's a graph there, just a picture showing what's composed in aerosols. What everybody's concerned about lately is microorganisms. Microorganisms can also be called a pathogen that cause disease, bacteria, and then obviously with the COVID, occurrence, want to call it a crisis, everybody's worried or concerned about viruses. Just how do particles work? This is a graph that I found, or a picture I found on the internet. The white shows the cross section of a filter fiber, and the little dark circle is a particle. So first we have inertial impaction, also called impingement. That's when the particle actually physically hits and sticks to the fiber. Next we have straining, where the particle gets caught between 2 fibers. Next we have interception, where the particle is about to pass the fiber, the filter fiber, and then it gets drawn and attached to it on van der Waals bonds. Diffusion is for very small particles where they travel back and forth and bounce off other very small particles and then eventually get stuck on a filter. And then electrostatic, everybody should be familiar with this, is just the attraction of positive and negative particles. There's a picture of just a diffusion. And then just in general, the smaller particles are trapped mostly by diffusion, larger particles by impingement or inertial impaction, and then just the electrostatic attraction is basically for all particle sizes. So just when we're talking about viruses, they are very small. This chart here just gives a understanding that today we'll be talking about the size of these particles in microns. There's the, on the upper right is the description or just understanding of how big a micron is. In terms of size comparison, the human hair is 40 to 120 microns thick in diameter. Naked eye, what you can see is approximately 40 to 60. I'll use my same joke as last time that this is obviously age dependent. And then just to understand that viruses are very small. They're traditionally only seen with a micron electron microscope. Again, the SARS virus that does cause COVID-19 is less than 0.14 microns in diameter. So it is obviously extremely, extremely small. Just how is SARS, the virus, spread by airborne? There's a picture of somebody there talking or coughing or sneezing, could be also singing. This graph here, or rather picture, depicts this. I think this is from tuberculosis, but basically you have an infected person that coughs or expels these viruses. They're typically larger size, where point A and point B, where the virus is covered by a mucus water encased. As the particle is in the air, the water mucus starts to evaporate, and eventually the actual virus is exposed without any mucus covering it. At this point, it's called a droplet nuclei, and this is when the virus is, at that 0.14, extremely small size, could float in the air. Here's a picture that's from the Ashrae Epidemic Task Force that gives an idea of the size or just what happens with the particles as they travel. So point A and B above would be considered the blue globes, where they're also called a respiratory droplet. And then point C, where there's no mucus and covering, would be considered to be an aerosol. Here's a graph just giving, once again, an understanding of the breakdown of all the particles that are present in air. Just want to highlight down at the bottom that the very small particles, 1.0 and 2.0 and smaller, make up more than 90% of all the particles that are in the air. And then just what the HVAC industry has grouped these particles into 3 different sizes. There's E1, E2, and E3, and they have the different micron sizes as listed on the slide there. Once again, everybody should be very familiar with this. Another thing everybody should be familiar with is the Ashrae standard 52.2. This is the latest version, is 2017. This establishes a test procedure for evaluating performance of air cleaning devices as a function of the particle size. This was a great standard once it came out because it eliminated a lot of uncertainties before with the filter industry. Everybody's familiar with the MERV, the minimum efficiency reporting value. 1 is the lowest, 16 is the highest. The highest value has a better filtration effect. Just in general, these MERV ranges, this is the range of MERV sizes and what particle size they're effective at filtering. And then just a comparison to you old timers, and including myself, is traditionally a MERV 8. Now a MERV 8 was equivalent to a 30% efficient filter back in the day. MERV 11 was 65%, and then MERV 13 was 85%. Another graph that everybody should be familiar with, this is from 52.2. This is a chart, table 12.1, that has your different MERV ratings from 1 up to 16 on the left. And then it has the filter efficiency based on 3 different range of particles, the E1, E2, and E3 that I mentioned before. Just want to point out that HEPA filters and ULPA filters are not per 52.2. And then also too, just want to highlight just the 2 charts, or just two of the filter sizes here. Just you can see on the left, from the very small 0.3 to 1.0 micron range, there's a pretty significant difference between the MERV 8 to MERV 16 filter in terms of how efficient it is for filtering. But then once you get to the range 3 with the bigger sizes, you can see that the MERV 8 to MERV 16 only has a difference of 70 to 95% efficiency. So it's not really that great of a difference. So just kind of remember that concept later on when we talk today. So filters work in series with the effectiveness at reducing particles. Looking at the range number 2, the E2 from 1.0 to 3 microns. Here's a cutaway view of a simple air handling unit. We have your airflow traveling from left to right. You have a MERV 10 pre-filter and a MERV 13 final filter, also in the in the upstream position. The E2 has a 50% efficiency from the chart, and then the MERV 13 has a E2 efficiency of 85%. So our air starts out entering the equipment upstream of the pre-filter. We're at 100% particulate. As it passes through the first filter, at point number 2, we've effectively removed 50% of the particles. And then as we travel through the second filter then filters 85% of the remaining 50% particles. So now at point 3, we're down to 7.5% of our initial 100% of our particles. So that's how filters work in series. Once again, we'll talk about that, or just remember this concept later on for today. Other ways to improve your indoor air quality, back to under air disinfection. Everybody's familiar with air ionization. This is a process by which atoms or molecules acquire a plus or minus charge. Bipolar means that you have both positive and negative ions. So here's a cutaway view. Just the ionization uses an electrical charge to create a plasma or electromagnetic field. And as the air and particles pass through the field, they become ionized. They become ionized, sorry about that. And then just this air cleaning system, multiple manufacturers, they reduce particles, they reduce VOCs, and they reduce pathogens. And just what I'd like to try to emphasize or just pivot a little bit today is that instead of being so focused on pathogens, it seems the building readiness standard is pivoting towards reducing particles. So just keep that in mind as we continue on today. How does the ionization work for reducing particles? Basically, it takes many small particles, they become positively and negatively charged. They clump together, the term is agglomerating. And then those larger particles become easier to trap in your filtration system in your HVAC equipment. For your VOC reduction, what the air ionization does is it breaks your covalent bonds. So here's an ammonia molecule consisting of nitrogen and hydrogen. As it goes through your air ionizing field, it breaks down these molecules into less objectional forms, and then they regroup. So here's just an example showing nitrogen, how nitrogen is formed from ammonia molecules that have been broken down. Lastly, reducing pathogens. The positive and negative ions attack the DNA structure. Don't have a cool graphic or picture showing that. And then just some manufacturers do have third-party laboratory testing that we'll discuss just a little bit further on. So just be careful, there's differences between air ionizing manufacturers. They have different ways that they generate the electromagnetic field. They can use bulbs, bars, or needle points. There's different products for different equipment airflows as shown on the two bottom pictures there on the right. You have different electrical requirements. Some of them require one-phase power. There's other ones that you only have to, you can provide with 24 volt. And then also too, there's different maintenance requirements for different manufacturers. And then lastly, just realize that there's different approved locations. This is just showing multiple spots. You have upstream, downstream of your cooling coil, in your fan section, as well as in your ductwork. And then just in general, the closer you are, the closer your air ionization device is to the space, the more effective the air ionization you'll have in your occupied space. Just the air ionizers do create, some of them do create ozone. The ozone is created by taking oxygen molecules and then breaking them apart and then reconfiguring them with 3 oxygen molecules. Ozone is not a carcinogen, but it's one of 6 different pollutants that are that have been flagged by EPA, et cetera, like that. There's good types of ozone that everybody in the HVAC is familiar with, the ones high up in the atmosphere that shields us from UVC rays, and then, just UV rays. And then there's bad ozone that at ground level. So that National Ambient Air Quality Standard has a table from 2015 where they list ozone. There's a couple other pollutants obviously as well too. The average time and then the level of exposure. I just highlighted in yellow, and the yellow stars, there's a lot of different levels based on states, et cetera, like that. So just, I'm not an expert on actually what that level is, but just understand that, ozone is considered to be a pollutant. Upcoming in Ashrae in 62.1 in version 2019, they've created another section for ozone generating devices. Under 5.71, they have air cleaning devices, and they're stating that an air cleaning device shall be listed and labeled in accordance with UL 2998. Now, what is 2998? This is a manufacturer's standard for ozone generation, a compliance. There's 2 different ones. There's 867 as well as 2998. They have different levels of ozone generation. You can see that the UL 2998 is more stringent versus the 867. If the manufacturers do qualify or they become certified, they get this ugly green little sticker. And then where you can find what products are approved for UL 2998, if you go to that link there, under products, if you search for 2998, it will bring up a list of different manufacturers. Just this morning, I went and looked on, and they had results for 23 different products. Okay, other ways to improve indoor air quality from our air disinfection. UVC lights, everybody's familiar with them. We're using the UV germicidal. It's used to kill or inactivate microorganisms. The UVC lights have been optimized for HVAC at the 254 nanometer wavelength. Just how they work is the DNA and bacteria virus absorbs the UVC, it changes their structure, and then they can't reproduce and they become inactive. Traditionally, UVC lights were sized for surface coverage only. There's a picture showing the lights installed on the downstream side of a cooling coil. So light would affect any growth on the coil as well as the drain pan. Traditionally, those bulbs were sized for approximately 5 to 7 watts per foot. But just what has happened with the COVID crisis is now UVC lights are being sized for on the fly, whereas the air passes across the UVC light, the exposure, it will have the same effect as before. But just now we have a much shorter exposure time. So we're required to have more output, which means more bulbs. And then just a rule of thumb is for on-the-fly sizing is using approximately 500 feet per minute. You can see our output has essentially doubled and tripled from the surface coverage only. Where you can locate your UVC, the most common is downstream of your cooling coil. You can also install it upstream. There's these positive and negative features. And then lastly, also can be put in the ductwork. It's not really done just because of the access to it, as well as it's not really working on your cooling coil, which was what it was traditionally originally mostly used for. Okay, next let's review the Ashrae epidemic publication for building readiness. This is originally came out last year. It's been updated a few times. The last update occurred in beginning of February. So now it's up to 143 pages. The intent is to provide practical information for how your building shall be operated. And then they have specific recommendations for ventilation, increase filtration, as well as flushing calculations, et cetera, et cetera. In the version, here's a snapshot of just, I've highlighted under the epidemic conditions in place in yellow what items have changed. The main ones, or the two ones that I'll talk about today, is equivalent outdoor air, and then the filter droplet nuclei efficiency. These are two new sections that were completely added. You can see 16 and 17 pages, so they're pretty significant. Just before getting into those two topics, just want to paraphrase from page 45. Just want to emphasize once again that filtration bypass is bad. This is when air is not traveling through your filter. So you want to make sure your frames and filters are installed properly. There's a picture there just showing a couple of box filters sitting in a frame. Just the standard, or sorry, the guidance does show a chart with, they have different MERV ratings of 6, 11, and 15. And then they say as a 1 millimeter gap, you have this much of reduction. So a MERV 15 becomes a MERV 14 with a 1 millimeter air gap. And then you can just see when there's a 10 millimeter air gap, there's a much larger reduction in your MERV rating. Then once again, from a perspective, this here just shows, what's 1 millimeter equal to in inches, and fractional inches into millimeters, et cetera. So now let's get into those two new topics. They have a pre and post occupancy flushing strategy. This is done to remove bioburdens in the space. You're going to operate your system before or after occupancy. And I'm going to kind of summarize and paraphrase a lot of these slides here just in terms of time and streamlining it. Just basically your contamination space, your contamination that is in your space is a product of how much air is flowing in and how much air is flowing out versus a time interval. What the objective is you want to reduce your space's concentration of infectious particles by 95%. In other words, you're going from 100% down to 5%. For a well-mixed space, they're saying that this would require 3 air changes per hour. And then the default is you could operate your HVAC system for 4 hours before or 4 hours afterwards to properly flush the space. Or what we'll talk about or go through is the ability to, if you calculate your equivalent outdoor air quantity, you can reduce that 4 hours down to a certain number of minutes and et cetera like that. So equivalent outdoor air on page 26, what they want you to do is provide clean air to flush out your space. There's 3 sources of clean air. They're assuming that your outdoor air is cleaner than your space. You have recirculated air that is traveling through your HVAC system. This is subject to your filtration and air cleaning technologies. And then if you do have a portable device in your space, that would also qualify for cleaning or flushing out your space. Here's the calculation. It's equivalent outdoor air, it's based on air changes per hour. So you have your equivalent outdoor air based is a function of your 3 components of your outside air, your recirculation air, and your space air. So what you'll do is first you'll calculate your 3 different sources of clean air, and then you'll apply a zone air distribution effectiveness. Zone air distribution effectiveness, everybody should be familiar with this. This is in your Ashrae 62.1. This is where you apply a factor based on your supply and return locations in your space, as well as your temperatures of your air for cooling, as well as for heating. So calculating your equivalent outside air, this is the information that's required. Obviously, you have to know what your air flows are. And then in your space, if you have a portable air cleaner, they have a clean air delivery rate. You need to know that number. And then for recirculation, you should know what your MERV, what type of filter or filters that you have. And then just want to highlight that if you do have a UVC light installed in your system, you should know what that inactivation percentage is. And then just want to highlight that this equivalent outdoor air standard calculation is treating UVC lights as a filter. And then just want to point out that both of these, recirculation as well as your space, you'll take effect, or you'll just calculate that the filters all work in series. So 0.1 to 0.2 to 0.3, et cetera, like that. So instead of using a MERV rating percentages, the task force has created a filter droplet nuclei efficiency. Summarizing once again on page 36, they're assuming that the SARS virus acts like influenza A. So the SARS virus, the particle is sticky due to a lipid envelope, as well as being covered in saliva or water. And therefore, the viruses are clumping together with other particles, making them larger. Back to our little picture here from the standard. So before we had our respiratory droplets, the ones shown in blue, and then our aerosols. What the direction that the committee is going towards is that basically the spread of infectious diseases is more likely occurring due to larger particles. So what the committee then has done is said, okay, with those larger particles, they're going to anticipate the percentage that the virus is present on each of these three different particle sizes. Just want to highlight, once again, these are the E1, E2, E3 that we talked about before. And then just highlight once again that they're saying that 50% of the virus particles are present on a particle that's 3 to 10 microns in size. So how do they calculate your nuclei efficiency? They're taking your E1 particles times your efficiency, and then basically implying the different MERV rating efficiencies for the three different sizes versus your particle distribution up above. So here's back to our 52.2 chart, where you have your three different efficiency sizes. You can see they've created a droplet nuclei filter efficiency that you use for your calculations. Want to point out that the numbers in the E1, E2, 3 numbers in this is different than 52.2. There was a note that they took an average of like 140 different filter manufacturers. And then once again, just want to also highlight our E1 and E2, E3 particle averages, that the the droplet nuclei filter efficiency is taking into effect, the E3 average particles. You can see that once again, there's not that much of a difference between the E3 size versus the E1 size. So what they're doing effectively is they're increasing the efficiency, the filter efficiency performance of lesser filters, or filters with a lower MERV rating. All right, so here's, so they've created a spreadsheet. Here's just directions of how to find it. If you go to the Ashrae building readiness document, go to equivalent air. There's a link for an equivalent air outdoor calculator. It's available as a Google Doc or else Google document or an Excel spreadsheet. There's a README tab for README instructions, and then here is a little snapshot of the Excel sheet with the equivalent outside air calcs where you start putting in your information. So the guideline has an example from page 29 to 33 of how to calculate your equivalent outdoor air. They have a simple air handling unit with a filter. They have outside air, return air. They have filter, and then downstream of a cooling coil, they have a cooling coil as well as UVC lights. They have 900 square feet of space. You can calculate the air changes. There's a zone air distribution effectiveness of 1. They give your supply air and outside air CFMs. You can calculate your air changes. They have a MERV 10 filter, and then also a UVC light that's 95% inactive. Once again, realize that the UVC light is going to serve as a filter. It's going to work in series with the upstream MERV 10 filters. Using an Excel spreadsheet, and you plug in your numbers, our total equivalent outside air is 9.88 air changes. Now, what does that tell us? So the target was for 3 air changes, but we actually have almost triple that. So one air change is going to only take 18.23 minutes. So going back to our pre or post flush, so instead of operating it for 4 hours, we're able to operate it for 20 minutes. Obviously, operating your air conditioning system or heating your HVAC system for 20 minutes versus 240 hours saves a lot of time, as you know, especially energy. And then just want to make an observation about the building readiness is that the cleaning, you know, they're looking at cleaning or flushing the space of infectious contaminants. One is that they're taking a credit for UVC lights that's going to act as a filter. So if you have an inactivation rate of 90%, you have an equivalent to a 90% efficient filter. And then the other thing that they're doing is they're proposing that the virus is spread by larger particle size based on this chart here. Just sort of want to point out that air ionization, one of the functions that it does is that it agglomerates smaller particles into larger ones that make them easier to filter. But then just want to also point out that Ashrae hasn't changed their position about air ionization. They're still calling it or treating it as an emerging technology. The building readiness guide has a whole page, stating, their position or just how they feel about air ionization. All right, next let's just talk about what products we have available for your filtration and indoor air quality. First, we're going to talk about needlepoint bipolar ionization. HC&I represents GPS, Global Plasma Solutions. Just want to point out that this is, we're not the rep in Delaware, that's Building Systems and Services. GPS has been around since 1989. Over 250,000 installations. This has probably gone up a little since they should probably update that. Located in headquarters in Charlotte, they have developed testing facilities. Here's a couple of pictures of their available products. They're very flexible in terms of the size that they can be installed. Multiple locations, whether it's upstream, downstream of your cooling coil, in the ductwork or in your fan section. And then also too, these products also have minimal maintenance requirements. They do have a self-cleaning function. Not going to go into more detail on this, but GPS has performed third-party testing on pathogens. They've, there's a one-page summary that I can send to people if you wish. They have just done sensitivity trading where they have a pathogen in a Petri dish and they run their GPS products across it to see the results. They also have simulation testing where they have a sealed laboratory chamber and they have these different pathogens in there, and then they calculate how long they're in there, how long the GPS is running, and then what's the kill rate of reduction. Another interesting test that they've done, they're calling it a specialty test, where they have an unoccupied lab for conditions unique to a particular customer. On the right, it shows similar to a small private airplane cabin. What they did back last summer is that they put the SARS virus, the new SARS-CoV-2 virus, in 3 different sample locations. They had airflow flowing, highlighted just 2,200 feet per minute, and the average ion count in the chamber of 27,000. Obviously, from an HVAC perspective, that's much higher than you traditionally would encounter. The results were that the SARS virus on those 3 sample sites had an average reduction kill rate of 99.8%. Once again, just want to highlight that this is a specific test that was done with GPS as well as a airplane, manufacturer, specialty company that deals with interior cabins of airplanes. Other thing that GPS has done for third-party testing, they've actually tested particle counts before and after with needlepoint bipolar ionization. They took an air traffic control tower. They put an iMod GPS device in an air handling unit. They essentially ran it for a month. They then counted the particles before and after. As you can see from running the GPS product for a month with their standard HVAC system, they had an enormous amount of particle reduction in the space, over 85% for these 3 different sizes. Next thing to be concerned about with air ionization is ozone generation. Once again, we want to be careful. We want to be able to be certified for UL 2998. GPS has these products available that do qualify for the 2998. Once again, if you search on the website that I link that I gave you before, you can see all these different products are on that website. Just GPS's flagship product is the iMod. There's a picture of it in the center there. You have these blue, Lego-ish pieces with the generator on them. The blue box is your power source or your power. And then it is available with universal voltage. It is considered to be self-cleaning. The iMods can be installed, they should be installed in the Airstream, but the power source can be indoors as well as outdoors. As I mentioned, the self-clean, they have minimal maintenance. Picture there, they can be installed. That's a cutaway view of an air handling unit showing the 2 blue iMods being installed on the coils. Next, let's talk about UVC germicidal irradiation. HC&I represents UV Resources out of Santa Clara, California. They've been around since 2016. The UVC Resources as well as GPS has a good reference library in terms of what products are available, resources that are available or have been in the industry. They have support, newsletters, as well as blogs and articles. What their flagship product is for coil duct system is an RLX Stream. This is a picture of it here previously on this slide. It's available for mounting. They also provide all the ancillary devices with sensors, panels, safety stickers, et cetera, like that. The thing that we like being a sales force is that they have a computer selection program, so we can plug in your coil face area and then produce a couple of different outputs available for how many watts per square foot you're looking for. 2 other products that they do have available is for rooftop units, as well as a stinger for small fan coils, unit vents, et cetera, like that. Lastly, let's talk about portable air cleaners. This is a product or just an industry that obviously with the COVID crisis has become more to the forefront. Back to our building readiness guide on page 117. If you are unable to install higher filtration in your existing equipment, a portable unit located in high traffic areas could help with your air cleaning with your situation. Available components based on many different manufacturers. You have these different filter types available. Some of them come standard with UVC lights or bipolar ionization, or some of them have them as options. And then the different orientations that you have available is a recirculation one. And then a few other manufacturers have ducted options for ducted, where you can connect a piece of ductwork and help distribute the airflow in the room better, or else you can duct the exhaust to outside of the room to create a negative differential in the space. What they're looking for is you want to reach a desired air changes rate per hour. Obviously, everybody knows how to calculate air change rate. The one thing I just want to point out is that the building readiness guide for the portable air cleaners does not say, okay, size the portable air cleaners for 1 air change per hour, or 3 air per changes per hour, or 6 air changes per hour. So HC&I has 4 different portable air cleaner options available. The first one is a company called Gallatin Air, their Cleanse Air product. There's a cutaway view. It includes a Mervate pre-filter, a HEPA final filter. There's UVC lights as well as bipolar ionization. It's available only for recirculation. So what we, before repping this product, we asked them to send us a sample so that we could test it out. We wanted to make sure that it worked as advertised. So in our King of Prussia office, we did an informal product test. We took our conference room, which I'm sitting in now, and then we ran the Gallatin Air unit for 4 hours. So our conference room here is about 350, 400 square feet. The Gallatin Air unit at 250 CFM resulted in about 3.5, 4 air changes per hour. With the implementation of GPS, et cetera, like that, we've purchased some handheld particle meters. What we did is we measured the particle sizes of 0.3, 3, and 10 microns. We did this before we started our informal test, and then we ran the Gallatin Air unit for 4 hours. During those 4 hours, at 3 different locations, we recorded the different particle counts on those 3 sizes. And what we found is that running the Gallatin Air unit in this conference room, after 1 hour of operation, the particle count was reduced by about 50%. We went back in at 2 hours and then at 4 hours, and essentially at 4 hours, we were able to reduce our particle count down to 60%. So our original particle count was at 100. After 4 hours, we were down at 35 and 40%. And then just want to emphasize that this is a HEPA filter plus air ionization. Other products that we have available, next is Nailer. There's a link to the website. It's available in this sizes, these filters and these options. We also have Temp Spec and Aerometic. Once again, there's a recirculation only. These are the sizes. This is the size that's available. And then these are the filters that are included. And then there is options, once again, for UVC lights and bipolar ionization. The last option that we had, want to just point out that we have a carrier OptiClean. Just HC&I is not the carrier rep in Philadelphia region, as well as Delaware and New Jersey. The OptiClean has 2 different sizes. This one here only has a filter and HEPA filters. They don't have options for a UVC light. This was one of the Time's Best 100 inventions. I think that's the total for 2020. Excuse me. And then the thing that's different about this one is that it could be used for recirculation, but then it also could be used as a negative air machine. If you look on the picture there on the left, this is showing use in some type of healthcare facility, but you have your air being drawn into the OptiClean unit, and then that black flexible duct on the top is exhausting it outside. So it's creating a negative environment in that healthcare situation, all right? So summarizing, we have our Ashrae Epidemic Task Force. They would like to have you flush the space with clean air to remove infectious particles. You're going to do this by delivering outside air. Delivering outside air, ventilation, could also be considered to be called dilution. You have your filtration and cleaning technologies. This is for your recirculation air in your air handling unit, as well as your space with the portable air conditioner. Portable air cleaner. And then just, put in red and want to kind of question, just looks like the direction that they're taking is that the infection is spread by larger particles. And then once again, just wondering, would air ionization help? And then lastly, just HC&I has these indoor air quality products available. The needlepoint bipolarization by GPS. You'll improve your filtration effect using air ionization. We have UVC lights for pathogen inactivation. And then we have 3/4 different portable air cleaners that have all different price points and sizes and availabilities. And then also, what options are available inside of them. All right, use my voice a little bit. All right, so just summarizing, now we'll start taking questions. Just as Buck said, want to point out, that we have on April 20th. We're going to have Jeremy White come back. This time he's going to talk about makeup air for commercial kitchens. So I get a break until May. And then in May, we're going to talk about DOAS units and the psychometrics of DOAS units. Want to make sure people are discharging their supply air from your DOAS unit at the appropriate dry bulb temperatures, but especially at the appropriate grain levels for your spaces. All right.
All right.
Okay.
Hey, real quick before we get into the questions and answers, we had a drawing for a stereonizer giveaway, which is a small bipolar ionization desk, like a desk fan device. The winner is Jeff Ludwig from West York School District. Jeff, if you want to get in touch with me, shoot me an email. We'll make sure we get that down to you. So, all right. So we had 2 answered questions during the during the seminar. One was about the DOAS psychometrics, when the date was, which is May 25th. Second question that was answered was UV lights. Is that watts per square foot of watts per square foot or per linear foot? The answer is watts a square foot. Question from Dave Burkett. For BPI, can you measure the effectiveness in the space? What quantities of ions are desirable?
You can measure the ions in the space. They do have handheld ion counters. Sort of a loaded question that there hasn't really been any ionization quantities qualified or I'll say qualified. I've seen some statements, et cetera, like this. I attended a presentation where somebody said that if you have 7,000 ions in the space, you're attacking or treating viruses, and I would not go on record as saying anything like that. Just to emphasize that the those values have not been established. I'll just say from our experience, we've recorded 2,000 ions. A space had 800, and we've recorded 2,000. We've recorded 20,000. A lot of it depends on your there's so many different factors affecting those numbers in the space. Activity. An example is we had 2 rooms side by side. One of them had carpets, the other had hard floors, and it just had the spaces were about the same, occupancy about the same, but had 2 totally different ion level readings.
Okay. Next question is, what type of BPI are in portable units? Are they ozone compliant and film ranges?
I think the question was in the Gallatin Air units, what manufacturers use, are they ozone UL 2998 compliant? I'll have to get back to you. I don't think that information has been provided to us. This is the first time I've been asked it. So let me write a note and we'll find that out and let everybody know.
And as far as the CFM ranges go, the Gallatin Air unit is 200, was it 250 CFM?
Yes.
Yep. And then, the Naylor unit goes up to, I think, 2,000 CFM.
I think it's 700. The carrier one has 2 different sizes up to 1,500. Just okay. What we've seen on most manufacturers is they have a, like for the airflow, they have a little potentiometer. So it seems the mode of operation is to run the portable air cleaner at high during unoccupied and clear out the space. And then once people do return, we've seen, customers dial back to, 50% or, 75 or 25%.
Okay. Question from Michael Sparks. The use of portable units was mentioned to be used for a few months. Is the intent that this is temporary until the system could be modified to increase the recommended equivalent filtration?
Yeah, I don't know if that's really considered a temporary fix or it's a permanent fix, but it all depends on your existing system and how, what's the ability to modify it. What's the, what additional MERV effect filters can you install? Does it affect your fan performance? Does it affect your airflow, et cetera, like that? It's sort of a, question hard to quantify. If a portable air cleaner costs $1,000 or $2,000, to buy versus, $8,000 to modify your existing system, then, from an economic standpoint, it would make sense to, do the portable. Not sure if I answered that, Mike.
All right. Question that ended up in the chat. Can you speak of germicidal lifespan and maintenance for the lamps?
For the lamps, they're typically they typically last about a year, and then they do also sell UVC meters where you can install those in the Airstream or in the UVC light and measure that. So they're typically they last about a year, and then they have to be replaced. Just realize that the UVC lights do contain mercury, so they have to be properly disposed. And then also too, when you're replacing the UVC bulbs, you have to use gloves to handle them. You don't want to use your bare fingers because the dirt or the sweat or the oil on your hands ends up causing a problem on the UVC lights.
All right.
And then if I can just interject with the air ionization maintenance. For all, there's some manufacturer, there's differences between the different manufacturers. There's different maintenance requirements. The ones that seem to use a bulb, a bulb to create the air ions, those bulbs last about 2 years and then have to be replaced. So, so the UVC lights are like 8,000 hours a year. The bulbs are 16,000. The GPS products, as well as other ones that are using brushes and cetera like that, those don't really have, some of them have like what will end up happening is the brushes or the generators will end up getting dust on them. So some GPS has a little wiper that cleans them. You can set it up for once a day or once a week, et cetera, like that. And then typically, what they also require is just like when you're going to, quarterly, if you're going to change your filters, you should go and just make sure your GPS or your air ionization is running. And then you might have to, just wipe it down, simply with a cloth.
Now, but some Jim, have the self-cleaning mechanism, but the iMods have, you would have to go in and what is it, vacuum those brushes?
Right. Correct? Yeah, I think the iMods, how the particles form by positive and negative charges on them. So the iMods, reverse their polarity, thousands of or hundreds of times a second. So they self-cleaning, but the O&M for the iMod recommends to go in. I think it's once a year and to, wipe them down with a cloth.
Great. Thanks, Jim.
You're welcome.
All right. Any other questions before we wrap up? So we'll stick around for a few minutes. Jim, does that conclude our presentation?
Yeah, that's it. Just a reminder, I can get you the PDH credits. Just let me know. A lot of people already have. And then, once again, reminder, I'll generate a summary of the questions that were answered. Thanks to Buck, we'll get you a copy of the recording. And, we appreciate if you could, we appreciate you attending. And then also too, if you can help us out with how we're doing, et cetera, like that. If you can fill out the simple survey, we'd appreciate that too.
Great. Thanks again, Jim. How can I get credits?
Oh, if you got a credit, no. Just send me, if you haven't, send me an email, and then I can, once I've got like 70 or 80 certificates to make up. So once people start straggling in, I'll make them up and email them out. So just send me an email that you would like a PDH credit.
I'm going to just put your email address up there, Jim, so people have it in case they
Okay, it's on the screen in the lower left.
Great. All right, super. Thank you very much, everyone. Hope to see you next month, and have a great rest of your week.
Thanks for the help, Buck.
You're welcome. Thank you.